12s, welcome to our last unit that we're going to be able to complete in the month of June. This is unit number 5, so it's just the second half of equilibrium. So all the kinds of calculations we did in the first unit are really going to just carry through into this unit, where our focus is mostly on acids and bases and how they set up equilibriums. This unit, again, I would just print a few pages if you do have access to a printer. If you don't have access to a printer, that's okay too. But what I want you to think about is that there's a review package within the notes, and we refer to those in the notes here where it says equilibrium review, do questions 1 to 3. So, for example, those are the questions that go along with the lesson we're going to do today, and they are in the review package, and the package is pages, 9 to 14. Okay, so what I usually get students to do is to take these pages out, staple them together, and then work away at them, and then this becomes the package that they're going to use for a review for the test. So this unit doesn't have a sample multiple choice test at the end because we generally use the review package. Okay, so for this unit then, if you have a chance to do that, if you can't print it again, just summarize it as best you can. This is what will get you to just show me as some evidence of learning at the end of the unit for this one, okay? All right, so that's where it says review questions 1 to 3. That's what that means in the package. All right, so here we go. So for today's lesson, we're going to start by just looking at something that we've already kind of gone over before. We're going to look at being able to predict if a single displacement reaction is going to occur or not, okay? And so this leads us into figuring out whether reactions go to completion, or what if it's going to be a double displacement reaction? Is it going to be one that goes to completion, or is it going to be one that sets up an equilibrium? So just like the last unit, there are things that push, or driving forces that push a reaction to get to an equilibrium. Now we're going to just look at, well, what do those products look like? And if there's something there where ions are available for a reverse reaction, then an equilibrium can actually exist or not. Okay, so the first part of this is what I've got highlighted down below right here. Predict if a single displacement reaction is going to occur or not. And there's something called an activity series for metals. It basically gives you a list of metals, tells you which one's going to react and the rate at which they're going to react if you compared metals on this list, okay? So you can see right here that potassium, you know, is a fairly reactive metal, and you probably already know that, general trends that you've learned since grade 10 and grade 11. But this, again, is a list that you'd be provided on a test, and you'd be able to just look it up. Okay, so if it's higher on the list, it'll actually displace or replace the next one down below. There we go. My page is just a little bit slow. Here we go. Okay, so for the first one here, there are 2 trends again, and what I want you to do is just highlight the trends and then think about what these mean. So here's the first trend. A metal that's higher on the list will displace any metal that's lower on the list that's part of a compound dissolved in water. The higher metal loses its electrons more readily and therefore is more likely to react with the non-metal. This probably reminds you of what we did when we looked at in electrochemistry, when we did this demo again, right, with the copper and the silver nitrate. How do we know that copper actually does the reaction and it's not the other way around? Well, we can figure out which one gets oxidized, which one gets reduced, and then we also know that there are certain metals that are more reactive than others, all based on the atomic structure and what it looks like, the electrons and how many valence electrons, etc. Anyway, you just have to look on the list. So for the example that we've got for this one, you're going to compare aluminum and iron. So have a look on the list, find aluminum, find iron. You'll see that aluminum is higher than iron. This reaction actually exists, and you can see with the chemical reaction right here, and of course that reaction does go to completion. It is a single displacement reaction that occurs. The second thing that's summarized on this page is this point right here. So you want to highlight this one. The farther apart the metals are in the activity series, the faster the rate of the reaction will be. Okay, so again, this is just like an application question here. Find potassium and hydrogen, then compare magnesium with hydrogen. Which one are further apart? The spread between potassium is greater, so which one's going to be faster? The potassium's going to be faster. So again, you can use that activity series to do some predictions about the rate of a reaction. All right, next, here's where you write it out, your equation. Don't forget that we learned how to do ionic equations as well, all right? So this just gets us practiced at looking at the states of the product that we get, what ions are going to be available in the solution, and it just gets you to practice that. So there's a few questions you can do. Question number 1, question number 2, those follow up with the single displacement reactions and using the activity series to say, yes, this reaction will occur, or no, this chemical reaction won't occur, and then you don't write it out because it doesn't actually happen. The next part of this is looking at a double displacement reaction. And based on what gets produced, the products, you're going to be able to predict whether this is a reaction that's going to go to completion, okay? Is it going to have an arrow like this? Or is this going to be a double displacement reaction that sets up an equilibrium? And then you're going to write your chemical reaction with an equilibrium symbol in the middle. So how can you figure that out? How do you predict what's going to happen? Here are the rules, and the rules are on this little page right here. So the bottom of page number 6, this is where you want to memorize your rules and then be able to come back to this page here so that then you can do the questions that are on the following page. So 3 quick points. If the product that gets formed is a precipitate, then this double displacement reaction is going to go to completion. And that should make sense because if it makes a precipitate, then the state that that product is in has an S beside it because it's a solid, because you made a precipitate. So the ions are stuck together. They're not available in solution. If the ions were available in a solution, then they're available to be able to get pushed into an equilibrium and go the other way. Does that make sense? So, does a displacement reaction occur? Do you get reactants and products, everything going to completion? You do if one of the products is insoluble because you make a precipitate. The second thing is if one of those products is unstable, it breaks down, makes a gas, makes water in the liquid state, and then guess what? There are no ions also available for it to get an equilibrium and go back the other way. So that's the second thing that can make a double displacement reaction occur. Okay? The third thing is going to be what we get into with acids and bases. So this is, do you have an acid that's strong or weak? Do you have a base that's strong or weak? And we're going to memorize some of these coming up in the next few weeks. If it's a weak acid or a base, think about what that means. That means that less than 5% of it is actually dissociated into ions, which means it's still stuck together, which means the ions aren't available for a reverse reaction to occur. And so weak acids and bases actually mostly stay together, and then the ions aren't there for an equilibrium. So if one of the products is slightly dissociated, i.e. a weak acid or a weak base, then it's going to stay as such and it will go to completion. Okay, so those are your requirements that you're going to come back to and look at for the next page. All right, of course you're going to need a solubility table because if you make a precipitate, you have to double check, right? Is this soluble or not? If it's one that's tricky because it's not just the general solubility rules that we've been over 100 times, make sure you use the table and just see, is it soluble? So therefore it's aqueous. If it's insoluble, that's the one where it shows it as a precipitate, as a solid. Okay? All right, so let's write equations for some double displacement reactions, and I'll talk about these. I'll go through a few of the examples on this page, okay? And that's it for today. So for double displacement reactions, we're going to determine those 3 things. Does it make an insoluble product? Does it make an unstable compound that produces a gas? Or does it produce a slightly ionized weak acid or base or water is produced? And if any of those criteria are met, then you're going to make sure you show that double displacement reaction as going to completion. And if it makes any of those, then it's going to, or doesn't make any of those, then it's going to make sure you've got ions available so an equilibrium can exist. Okay, so how would you do that? Write the balanced equation, write your ionic equation, write the net ionic equation if it's applicable, and answer the question. So for the first one, calcium bromide and sodium carbonate. The product of these is calcium carbonate, okay? So you look it up in the list. Do we know if that's a precipitate or if it's aqueous? Yeah, we can see that it's a solid precipitate, so you're going to put an S there. What does that mean? That means that this is a reaction that's going to go to completion. So when you write it, you're going to write it as a completion arrow. Yep, this reaction actually goes to completion, and here's why. You can see that in the balanced, the ionic, and then your net ionic equation, you can see that. That's the first example. Let's try another one. What if you've got, oh, my page is lagging again. Okay, there we go. If I've got sodium carbonate and nitric acid, the product that I get is H2CO3. I gotta look on my list. That one was one that was unstable, which means it decomposes into water and carbon dioxide. And then look what you've got. You've got water in the liquid state. This is a double displacement reaction that goes to completion, so you're going to write your completion arrows. Next one, ammonium cyanide and nitric acid. The product is a weak acid. And again, what we're going to do is we will memorize our lists of strong acids and strong bases, and then by default, the other ones are going to be weak acids and weak bases. So that's sort of coming, but right now you could just look that up if you'd like. And what do we remember? Again, we remember that if it's weak, it means that you have most of it still stuck together, even though you write it as aqueous, okay? Even though this right here is written as aqueous, look what you're going to do in the ionic equation. You are going to keep it together because most of it stays together. That's new, okay? That's one of the new concepts in this lesson. If it's a weak acid or base, recognize it as weak. It's still aqueous, but do not break it up into its ions because in reality, hardly any of them do. Okay, do you get that? No, that's tricky. All right, next one. What do we have? Copper 2 nitrate and potassium sulfate. No precipitate, no unstable compound, no weak acid or weak base. Guess what? This is one that produces a dynamic equilibrium. So when you write it out with your balanced equation and your ionic equation, you write your equilibrium symbol, and you've got all those ions available on the reactant side and all on the product side. So you could essentially shift that equilibrium any which way and apply Le Chatelier's principle to that one, couldn't you? Okay. All right, that's it for today. So you're going to answer these little questions at the bottom of page number 8 as well. So remember, there was some at the bottom of page 6, a couple questions at the bottom of page 8. And then if you feel good about that and you're ready to go, you can now answer the review questions 1 to 3 in this little review package. Okay, I will post a solution set for these so you can just sort of do your answers and then check it if you'd like as you go along. And then that's our first module. So that's module number 24. We'll talk to you on Wednesday. Good luck.